Hi everyone, in today's lesson I'm going to talk about the different components of trig graphs. So at this point I'd like you to pause the video and write down the definition that you see here, which is for amplitude, and the two examples below. Once you're ready, hit resume and I'll go through the explanation. Okay, so amplitude. By definition, amplitude is the distance from the midline to the max or min value. And remember, something to keep in mind is that distance is something that's always positive. So let's take a look at the two examples that I have here. So my first example is a sine curve. It's a sine curve because it starts at the origin, right? And example number 2, you can tell doesn't start at the origin, but starts up at the maximum. So therefore, that would be a cosine curve. So it's just helpful to write down some information. So we know that we have a sine curve because it starts at the origin. So we could say because it starts at 0, 0. Okay, same thing for the second example here. We could say we have a cosine curve because it starts at the max. So it's just a good habit to get into to recognize the two different pictures. So amplitude, again, we said was the distance from the midline to a max or min value. So I need to first discuss what a midline is. So I'm going to label this x-axis here as my midline. Same thing over here in example number 2. I'm going to label the x-axis as my midline. Now, by definition, a midline is the middle line between the max and the min values. So I'm just going to write that over here. So it's the middle line between max and min values. So middle line between max and min. So I mean, that kind of makes sense here, right? If I went as high as 2 and as low as -2, the middle would have to be 0. Same thing in example number 2. The highest I went was 3 and the lowest I went was -3. Therefore, the middle has to be 0 again. So if we read the definition of amplitude one more time, it says it's the distance from the midline here to the max or min values. So my amplitude in this problem is from here to here. That's my A. From here to here, label that with an A. So how far did I go from my midline to this max value? Well, look over here. I went 2. So from here to here is 2. Same thing as if I went from this midline to the minimum, the distance here is still 2. Although I went down, it's still positive. So over here, we can just write down that my amplitude is in fact 2. So that is the answer to the first example. Okay, let's look at the second example. So again, midline is the distance from the max value to the midline. So this distance right here, you should be saying is 3. Same thing here, from the midline to the min value, that is still 3, even though it's negative. So if you want to label it, from here to here is my amplitude, and from here to here is my amplitude. And in this case, the amplitude is 3. Okay, that's it on amplitude. So let's move on to the next slide and talk about another definition called cycles. Okay, at this time, I'd like you to write down the definition of cycles and then the two examples, and then hit resume when you're ready to continue. All right, so the main part of this definition is this part here where it says from 0 to 2 pi. So if you notice from the two examples that you see here, this cycle happens from 0 to 4 pi. And these two cycles happen from 0 to 2 pi. So you're going to notice that when I give you examples, the x-axis is going to change. So in order to answer the questions about cycles, you have to know how many full rotations you see in this interval, so 0 to 2 pi. Okay, so let's trace out how many full rotations we see between 0 and 2 pi in each of these examples. So we're starting at the origin, and we're going to stop when we get to 2 pi. So in this first example, I've only finished half of a cycle of sine. So to answer the question, what is the number of cycles? The answer for cycles is 1/2. I see half of a rotation between 0 and 2 pi. Let's look at example number 2. So we're going to trace starting from the beginning until we get to 2 pi. So 1, 2. So 2 cycles from 0 to 2 pi. So my cycles in problem number 2 is 2. I see 2 cycles between 0 and 2 pi. Okay, let's try a couple more examples. Okay, so take a minute, pause the video again, and write down these 2 examples. And then hit resume when you're ready to continue. Okay, so we're going to talk about another example now. Here's example 3. What you should notice in example number 3 is that the graph starts at the origin, so it has to be sine, but it's going down first. So that will tell you that this is a negative sine graph. So I don't see why we can't write that down to just help us remember that that's what a negative sine graph looks like. And if we want to draw what one full rotation looks like, we know that it starts down and goes back up again. So that is one full rotation of negative sine. And honestly, that's what I see, right? I see that it goes down, up, down. But we have to remember that cycles, to find the number of cycles, we need to see the graph between 0 and 2 pi. So this one, you need to use a little bit of an imagination. So you see how the graph here ends at pi over 2? It's not ending at 2 pi. You have to decide for yourself how many of these you would see if the graph went all the way to 2 pi. So you kind of want to just maybe draw a sketch, right? Here's 2 pi. And we see that every half, right? So from 0 to pi over 2, every half I see 1 cycle. So you want to know how many halves, how many groups of 1/2 would it take me to get to 2 pi. So I know that another 1/2 would get me to pi, right? Then another 1/2 would get me to 1.5 pi. And then another 1/2 would get me to 2 pi. So you kind of want to see between here and here, 0 to 1/2, pi is 1 cycle. You would see another one here that's 2 cycles, 3 cycles, and then 4 cycles. So the answer to this question is, for cycles, you would see 4 between 0 and 2 pi. So you really have to use your imagination to see, and it's a little tricky because it all depends on what information they give you. Now, let's look at example number 4. Same kind of concept, but now this time you should be recognizing that this is a negative cosine graph. So you should be remembering that one full rotation of a negative cosine graph starts at the minimum and kind of looks like an upside down, or it looks like an N, right, or a mountain. So you want to ask yourself, same concept, how many cycles do I see between 0 and 2 pi, right, if 2 pi were over here? So we know that we see one full rotation from 0 to pi, so really one more rotation would get me to 2 pi. So my final answer for the number of cycles is just 2. I would see 2 cycles, right? I could draw another one here if you want to see it, right? That would be your second cycle from pi to 2 pi. Perfect. All right, let's move on to one more definition called period. All right, so take a minute, pause the video, and write down the definition of period and the 2 examples that follow, and then hit resume when you're ready to continue. Okay, so period is how long it takes the graph to complete one full rotation or one full cycle. So let's just take a look at this first example here, right? We've got a whole bunch of mess here. You want to ask yourself, is this a sine curve or is this a cosine curve? And the answer to your question is that this is a negative cosine curve. And it's a negative cosine curve because it starts down here at, say, -1, right? That is our minimum. So therefore, this is a negative cosine graph. So in your head, you need to know what one full rotation looks like of negative cosine. And that's what it looks like. So the definition of period, like I said, how long it takes to make one cycle. So all this extra cycles here, it's kind of there not to trick you, but you have to look at the definition. You can't just say 1, 2, 3. I see 3 cycles. You need to know how long it takes to make one rotation or one cycle. So look, we start, we go up, we come back down. That right there is my one full cycle, up and down. So 1 full cycle, how long did that take? Well, just look right up here. It took pi. So the answer for a period is pi. It took pi to go 1 full cycle. All right, let's look at example number 2. So example number 2, it starts at the origin, so you should be thinking sine, and it goes up first. So this is a graph of sine of x. So we need to know what 1 full rotation of sine looks like. Again, start at the origin, go up, down, and back up again. So we don't have that, right? We only have from here to here. That's half of a cycle, right? We need to keep going. So you kind of want to imagine yourself, if I were to keep going, wouldn't it look something like that, right? That would be my finished product. So if it took from 0 to 4 pi to go half, how long do you think it would take to finish? Well, 8 pi, right? It would just double. So the answer to this question for period is, in fact, 8 pi. Okay, so now I'd like to put it all together. I'd like to write the equation given a graph. So take a minute and pause the video and write down these 2 examples and leave some space up here because I want to talk about the structure of the graph, and then hit resume when you're ready. Okay, so right here you can tell with these 2 pictures that they are starting at the origin. So these are both sine curves. So I want to show you the structure of how to make an equation. So when you make an equation for sine, you have y equals plus or minus a sine bx. And this is the form that all equations need to be in. So we need to define what a is and what b is. So a, I'm sure you can figure, is your amplitude. And b is your number of cycles that you see between 0 and 2 pi. So let's look at this first example. The amplitude should be very easy to see. So I started at the midline and I go up to the top. So my amplitude is 4, and down here, same thing, 4. So in my graph, when I'm writing my equation, it's y equals 4 sine something x. But notice how I left some space between this 4 here, because notice the graph went down first. That means it's a negative sine graph. Therefore, you need to put a negative in front of that 4. So it's negative 4 sine something x. So again, the b is the cycles. So we have to see how many cycles do I see between 0 and 2 pi. So I see 1 cycle from 0 to pi. So if I were to continue this trend, right, how long would it take to get to 2 pi? I would need another cycle. So 1 cycle, 2 cycles. Between 0 and 2 pi, therefore, my b is 2. So this is your final answer. All right, let's try another one. So in example number 2, we want to write it in this form. Y equals something sine something x. So we need to fill in a spot here and a spot here. So if we look, our amplitude is the distance from the midline to how high it goes, which is 10. The midline to how low it goes, which is 10. So that tells me that my amplitude is 10. Now I don't need to put a negative because I'm recognizing that the graph starts at the origin and goes up first. Therefore, it's a positive sine graph. All right, and now the next piece is the cycles. So how many cycles will I see between 0 and 2 pi? Well, it took 4 pi for the graph to finish, right? So wouldn't it make sense that 2 pi would be right here, this halfway mark? So how much of a graph did I see between 0 and 2 pi? Nothing other than 1/2. So, sorry about that. We're going to change this to say 1/2. So this is my equation. And that's it for sine. All right, let's do cosine, and then we're finished. So I'd like you to pause the video at this point and write down these 2 examples. and then hit resume when you're ready to continue. Okay, so just like before, we have y equals plus or minus a, but now this time it's cosine of bx. So this is the form for all cosine graphs. So again, a is my amplitude, if you want to write that down. So a is the amplitude, and b is the number of cycles between 0 and 2 pi. So I'm going to set up my equations down here. So y equals something cos something x. So if we look at this first example, the amplitude is what's going to go here. So the amplitude starts from the midline to the max value, or the midline to the min value, and that's 5. So we can go ahead and just type in 5. And notice that this is a positive cosine graph because it starts up at the maximum value, so there's no need to put a negative here. And then b is the amount of cycles I see between 0 and 2 pi. Well, let's see. From 0 to 2 pi, well, that's 1 cycle. So this one's not too bad. So put 1 right there. That is my number of cycles. So this is my equation for the cosine curve. All right, let's do the last one. So the last one is a negative cosine curve, and how I know that is because I'm starting down here. So let's set up our structure. So we have y equals something cos something x. So it's clear that my amplitude is from the midline to the min, or the midline to the max, and that's 3, right? So I can just go ahead and type in here -3 because it's a negative cosine graph. And then last but not least is going to be the b value, the number of cycles I see between 0 and 2 pi. Well, this one's a little interesting because 0 to 2 pi is only this part of the graph. So what portion of a cosine curve is that? You should be saying 1/4. So, keep doing that, sorry. So this is 1/4. All right, that's it for today. Have a good day, everybody.